Hello everybody, welcome back to another video. I'm going to explain to you how to use this equation properly that we have here. This is the Rydberg equation. So in the last video that I made, I forgot to mention something, and that is how to identify where to plug in. For example, in the question, they might ask you if we're starting in N1 or let's say in N5. Where do we plug these numbers here to find the final energy level that they want us to find? And let me explain that real quick. I'll try to be as fast as I can. So, first of all, let's start with something that confuses some people. First thing is that some videos they typically show this equation like this. Let's say this is final squared, they do initial squared. And if you do this, most of the time it works, but this only works when you're emitting. Oh, misspelled emitting. Yeah, this mostly works when you're emitting. Why? Because when you emit something, you go from high to low, high to low, correct? So for example, let's use the most common series that you see with these equations are these right here. The Lehman, the Balmer, and the Paschen series. The Lehman is 1, the Balmer is 2, the Paschen is 3. What does that mean? That means that n, they end in those numbers. That's what that means. So back to what I was saying. In a problem, most of the time, um, let me hold on. Here we go. In a problem, most of the time, when they say, uh, given let's say n2, an electron emits a certain photon, and they want you to find the other energy level. The key to this is when it says emit, that tells you you're going from high to low. And especially with these series, they always put either the 2, the 1, or the 3 here most of the time. And that's fine, but don't memorize that formula, because here's when it changes. Let's say they give you starting at N1, whatever. Oh, they say it absorbs, find the other energy level. If you do that, what I showed previously, you're gonna get the answer wrong, and this is why. Because when we're absorbing, you have to remember that we're going from low to high. So these actually flip. And why do they flip? Well, this is your biggest key to doing these. Let's take this one for example. We know that we have N01. They give us that, and they're telling us that it's absorbing. That immediately tells us that we're going from low to high. But in these series, you can't go lower than 1. You can go higher than anything, but you can't go lower than 1. And in this case, um, we can say Since we're going from low to high, that means that 1 is our lowest value. The rest of the values, the rest of these values, they're all going to be greater than 1. So using this, we can say that N1 is 1. Because the rest of these values, since we're going from low to high energy, the lowest one we have here is 1. So the rest of them should be greater than 1. And going back on the same note to, let's say we emit and we have, let's say we start with 5, correct? In this case, we're going from high to low. So 5 is here, correct? What this tells us is that we're going from the highest, which is 5, which is what they will tell you in a problem, to any of the other lower numbers. So for example, 5, 4, 3, 2, 1. And going back to this again, what this tells us is that 5, the number that they give you, 5 should be n equals 2. Because n equals 2 is always greater than the n equals 1. I don't know if this makes sense now, but I just wanted to show you because there's a lot of confusing um, formulas out there that some people don't um, they get messed up. But the key here again is um, always look at this and remember when the question is telling you if you are emitting or you're absorbing, and you use the number that they give you to find if it if that number is greater or if it's lower. So I'm gonna show you a problem just to put this in practice. Okay, no, there we go. So let me change color here. Can I hold on? Change color. Yeah, there we go. Color is here. There we go. Okay. So what I previously said, let's read the question carefully. An electron in the N6 level of the hydrogen atom relaxes to a lower energy level, emitting light of 93.8 nanometers. Find the principal level to which the electron is relaxed. Okay, so first things first. This is the Rydberg equation. And R of H here is 1.097 times 10 to the 7 meters inverse. So let's take a look at this carefully, step by step. They gave us n is equal to 6. And it's telling us it's emitting. So right off the bat, I know that we're going from high to low. Okay? Okay. They gave us lambda. Let me put, so you can see it. They gave us lambda. We have the Rydberg. Now, let's decide where to put n equals 6 we go back to what I showed you. Only looking at this, we're going from high to low. What this tells us that our highest number is 6, and we're going down. So we're going 5, 4, 3, 2, 1. We need to find out which of these numbers we're going to. So right off the bat, we know that n2 is always greater than n1, and our highest one here is 6. So n2 is equal to 6, because that is the highest one. We're trying to find where it's gonna land, basically. So we plug in the equation. This is 93.8 times 10 to the minus 9 meters, because that's nanometers. I'm gonna leave RH as it is. N1 squared minus. So here we have N2 we said is 6 here. There we go. Okay. So now let's get our calculator here, and let's plug in some numbers. Let me see. Oh wait, let me find the sorry about that. Okay, so this is how I like to start this. Let me see. There we go. Okay, perfect. So let's do the left side of the equation. So 1 over 93.8 e to the minus 9. We get a really large number. I'm just gonna write it down so you can see what I'm doing step by step. We have RH here. We have 6 squared. There we go. And now we're gonna divide RH. So this number is divided by this number. So get 1.097 e to the 7. I got 0.97183. Let me make some room here. So our left side of the equation looks like this so far. If you're following along, this is my calculator. I have n1 squared minus 1 over 6 squared. So now we need to move this number over here so we can leave n1 by itself. But right off the bat, we know that this is going to look like this. N1 squared minus 1 over 6 squared is 36. So let's move this to the left side. So we store that. Perfect. So 0.97. We subtract, so that's plus 1 over 36 plus 7. So let me make some room here. I'm already down here. 0.971. Oh, 1, 3 plus 1 over 36. For your calculator, you should plug in this number first and then add it. Don't do it like this, or if you do, just add the parentheses so you won't get over your number. But I got 999. This is n1 squared, but now that I'm seeing this, I think you're gonna see this too. Even if we take the inverse of this, because we need to get n1 by itself, get rid of this. Um, even if we take the inverse of that, I know. I mean, we just let's see. Inverse, we have a 1. We have a 1 over here, and we have n2. I mean, my bad. Sorry about that. That is actually n1 squared. So if you're following along, I took the inverse of these both two, and on this one I got 1. On this one I got n1 over n1 squared. The last thing we gotta do here is square root, but we know that n1 equals 1 because it's just 1. And that is the final answer. So again, two things to look in the question. The first thing is this, n equals 6. The second thing is if it says emitting or absorbing, and the rest is just algebra. Once you plug that into either this one or this one. But oh, please make sure that you plug this number into the right N1 or N2. And as I previously said, some other videos usually do this one as F and this one as I. It's because they deal with the series. So, like I said, the Bomber series ends in 2, the Lehman in 1, the Passion in 3. And since they end in those, that means that they're emitting. So that's why N1 is always on this side. I think I explained this because that's the lowest number we have. So we need to find where it came from, basically. But that is all for this video. Thank you for watching.